All right, so today we are multiplying rational numbers. So like I just said, we've added, we've subtracted, so it naturally makes sense that today we're going to multiply, and then of course, you know, dividing is coming in the near future. All right, so we're going to cover all the operations. So some important information, all right? So I need you to make a clear separation in your minds between your rules for adding and subtracting integers and your rules for multiplying and dividing, I guess we could say rational numbers, okay? So for example, with fractions, to add and subtract them, you have to have a what? Common denominator. But do you have to have an LCD when you multiply and divide? No, you do not. So we have a different set of rules for adding and subtracting and multiplying and dividing fractions. Same goes with decimals. Same goes with integers, okay? So the past couple of days, we've learned same sign, add and keep, right? We learned our song. That's for addition and subtraction. For multiplication and division, we go by what we call the even-odd rule. The even-odd rule, which says that you count how many negatives are in the expression, and that determines the sign of your answer. Okay, so don't say same sign and different sign. That's my addition rules, okay? So in the expression, if there is an even number of negatives, it will be a positive answer. If there is an odd number of negatives in the expression, it will be a negative answer. All right, so that'll make more sense as we start practicing, okay? All right, does everybody have their blanks filled in if there are any? I don't remember how many I put in there. Okay, a couple blanks, all right? Okay, so in example 1, the first thing I want you to do is I just want you to multiply the numbers, okay? So the multiplication here, guys, when you're looking at numbers 1 through 6, are these numbers difficult to multiply? Do you look at them and think, oh gosh, I wish I had a calculator? Hopefully you're shaking your head no, right? Because there are no calculators in this unit. I'm not giving you difficult numbers to multiply because that's not really what I'm testing you over. You have to learn what the sign of your answer will be. All right, so with that being said, what's 5 times 6? 30. So now I want you to hold up how many fingers, okay, how many negatives do you see in the expression? Hold it up. How many negatives do you see? All right, hold it up. All right, so I see 2, right? There are 2 negatives. Is 2 even or odd? Even. It is even. So my rule says an even number of negatives makes a positive answer. Okay? All right, so you got to separate the rules. This is not addition and subtraction rules. All right, number 2. All right, so do your multiplication. What's 3 times 4? 12. All right, now go back. Hold up. How many fingers, how many negatives do you see in the expression? Hold it up. Okay, is 1 even or odd? Odd. So your answer is negative. Okay, all right, number 3. Negative 25 times 0. Right? 0. Now, there is 1 negative, but is there such a thing as a negative 0? No. So my rule still applies for multiplying by 0. It's just 0. You're probably looking at it thinking, is there some kind of catch here or trick question? Okay. All right. So that one's 0. Now I want you to try numbers 4, 5, and 6. Okay. So we're using our even-odd rule to figure out what the sign of our answer is supposed to be. All right. Give you just a couple seconds. We'll pause here real quick. All right, number 4, hold up. How many negatives do you see? Hold it up, guys. All right, so what is your answer? Negative 24, very good. 1 negative is odd, so it's going to be a negative answer. All right, what about 5 times 5? 25. It's 25, so you say, well, I don't see any negatives. Well, then you know your answer is positive, okay? So don't get so hung up on the rule that it throws you off. A positive times a positive obviously will never be a negative. Okay, so 5 times 5 is 25. What about number 6?
9.
It is 9. Did you guys say 9? Just kind of nod your head if you wrote 9. Okay, so why? Not because it's same sign. Don't make that mistake. We don't call it same sign. You're confusing your rules. Because it's 2 and 2 is even. There's 2 negatives in there. All right? Great job on that. Any questions before we go to the next slide? All right. Okay, now we're going to apply the same rules to multiplying decimals and fractions. So the first thing I want you to do, guys, is do the multiplication. Then you will go back, okay? Then you're going to go back and decide what the sign of your answer is after you multiply, okay? Now, my rule for multiplying decimals is that the most digits go on top. Whatever number has more digits. Well, in this one, both numbers have the same number of digits, so it doesn't matter. I'm going to say 2.5 times 3.6. Okay, I'm just going to multiply the numbers. Go ahead and do that math. There's my pencil. Okay, so did you get 30 and 15 and 15 and 7? So when you added everything together, did you get 900? No. What are we forgetting? That decimal. How do you know how many decimal places to put in your answer, Zoe? Behind the decimal? Yes. How many place values are behind the decimals? 2. So you bump it over 2. Now, here's the question of the hour. Is your answer positive or negative? Negative. Why is it negative?
Because there's odd number of
Yes, there's an odd number of negatives in the original problem. So just put in the sign of your answer at the end. All right. So you might think that this is a test of multiplying decimals, but it's actually not. Now, you need to know how to do that. But more importantly, you need to know the sign of your answer. All right. Now, we've talked about fractions. What did I say about mixed numbers? What do you need to do to them? Change them to improper. With multiplication, you have to. Okay, with addition and subtraction, sometimes it works, but it's just better to change them all the way across. Okay, so we have negative 1/3. You can put the negative down there, okay, but you should be able to look at the original problem and know the sign of your answer. Okay, times negative. Now, what is my fraction going to be when I make it improper? Okay, 11 over 4. Now, the only reason I put parentheses here, guys, is because I have 2 signs here, times and negative. We use parentheses to separate that. Okay, that's the only reason the parentheses are there. All right, is there anything I can cross-reduce? I just need to multiply these fractions. Is there anything I can cross-reduce? No, so I'm going to multiply. Okay. What is negative 1 times negative 11?
11.
Is it positive 11 or negative 11?
Positive.
It is positive 11. Why?
Because there's 2.
Because there's 2 negatives and 2 is even. Okay, so 11 over 12. Positive 11 over 12. All right. Now, if you look back at the original problem, you could also see that your answer is supposed to be positive. Okay. So either way should tell you the same information. All right. How do we do on that one? Doing okay so far? All right. Guys ready? Okay. Uh-oh. It's freezing up. All right, so I want to give you about 2 minutes to multiply these numbers together. Go ahead and multiply these numbers. Now, if the fraction can be reduced, go ahead and reduce the fraction. So go ahead and try these 2 on your own. When you're done, I want you to compare your answers with a neighbor. All right, so 5.2, oops. All right, 5.2. All right, times 6. We'll worry about the sign in a minute. All right, we get 12, 31. How many decimals in our answer? 1. Did you guys get 31.2? And is it positive or negative? Negative. It's negative 31.2. All right, so for my fraction, I have negative 5/8 times negative 13 over 4. Can I cross reduce anything? Nope. I end up with positive 65 over 32 after I multiply. Why was it positive? Okay, because there's two negatives. If you said 2 and 1 over 32, that would be fine also. But you don't have to. You don't have to change it to a mixed number. All right. So let's talk for a minute about, about order of operations. Okay. So PEMDAS. All right. So let me write this down for a sec. Actually, let me switch screens real quick. All right. PEMDAS is please help me out. Excuse my dear Aunt Sally. What does P stand for? Parentheses. What does E stand for? Exponents. Multiply, divide, add, subtract. And we know that multiply and divide happens left to right together, and so does add and subtract. So we're going to follow the order of operations to simplify the expressions. Now, what do you notice that's different between these two expressions on the left? One is in parentheses and one is not. Okay? So there is a difference. Now, we do see an exponent as well. Does anybody remember what the exponent means? Yes, that number gets multiplied by itself that many times. So the negative 2, because it's in parentheses, you would write it negative 2 times negative 2 in parentheses. Okay, so now we can see how many negatives we have. So what would be our answer? Positive 4. Okay, now here's how the second one is different. Because there are no parentheses, that means the negative is not attached to the repeated multiplication. It's separate. All right? Simply put, your answer will be negative, always, if there are no parentheses. So this is negative 2 times 2. Okay? And your answer is negative 4. So the parentheses matter. They basically lock in that negative as a part of the base. So then it would repeat. Okay? Does that make sense? We don't hit on this too hard in this chapter later on in the year. Actually, not until the springtime. We're going to come back to this concept and really dig in a little bit more. Okay? So right now we just kind of scratch the surface on it. All right? Okay, let's look over here on this next problem. All right, what operation do you see all the way across? Multiplication. So we can use something called the commutative property here. We could also do that with the addition and subtraction. Remember when we kind of moved the terms around? Okay, so commutative property says I can multiply this in any order. All right, for example, let's take a time out for a second. What's 2 times 3? What's 3 times 2? So it doesn't matter what order I multiply in, right? Okay, so with that being said, what two numbers, don't even worry about the sign yet. What two numbers do you think would be easily multiplied together? 2 times 5. What's 2 times 5? 10. And then do you guys remember the rule? When you multiply any number times 10, what do? You just add a 0 after that. So what would be 10 times 17? 170. So you just did that entire problem in your head just by using commutative property. And I think you would agree if you had gone in order and done 2 times 17 and then that number times 5, you probably would have had to show your work. Would you agree? But when you use commutative property, you can make your life a lot easier and kind of rearrange. All right, you cannot do it with division though, because that changes the answer. Now, is my answer positive or negative? Why are you saying positive? Because there's 2 negatives. Now, there were 3 numbers, but how many negatives were there? 2, okay? So it's not how many numbers there are, it's how many negatives there are. All right, now on the last one, we have our addition coming back into the picture. So here we have to use our addition and subtraction rules. Okay? -3 plus 4. Same sign or different? Different signs. Subtract them. What's 4 minus 3? 1. And take the sign of the larger number. So it's going to be +1. -6 times +1. So you're going to see the rules start to blend back together. When it's addition and subtraction, you got to go by same sign, add and keep, different sign, subtract. You got to do it. Okay? Then when it's multiplication, what will your answer be? Why would you say -6? Because there's only one negative when it came down to multiplying it. You can't come back up here and say, well, there were 2 negatives in my original problem, because you had to do parentheses first. Then what did you multiply? 1 negative. Okay? All right, questions. How are you guys feeling? Thumbs up, thumbs down, kind of sideways? Okay. All right. No thumbs at all? Some of you are like, I'm not doing it. All right. Just kind of help me out with how you're doing. If I need to slow down or repeat something, let me know. All right. At first glance, does this problem make you excited? Let me rephrase that. At first glance, does this problem look easy? No. Okay. All right. Does it look like one of the harder problems you've seen? Yes. Okay. However, you remember the other day how I taught you additive inverses? What's an additive inverse? The opposite of a number. Now I'm going to teach you, and you can just kind of write it off to the side, what a multiplicative inverse is. I'm going to spell it out. Yeah, go home and tell your parents you learned about multiplicative inverses. I got to really think about this before I misspell it. Multiplicative inverse. Your parents are going to think you're just geniuses if they don't already. Okay? A multiplicative inverse says you can take any number and you can flip that number. You can do the inverse, the reverse. And then everything would reduce down to 1. You can cross-reduce your 2's down to 1. You can cross-reduce your 3's down to 1. Multiplicative inverses essentially cancel each other out down to 1. You know, if you multiply anything by 1, it's just the other number. So when you see a difficult, and I will call it a difficult problem like this, the first thing you need to do is say, do I see any multiplicative inverses where I see a fraction, but then if I were to flip that fraction, I also see the opposite? Because we could use commutative property to match them up together. Does anybody see a multiplicative inverse? Destiny. Very good. So we're going to match them up together. -1/7 times -7/1. And remember, the only reason I use parentheses is to separate a double sign here. Okay? Now let's bring down everything else. Times 4/5. I'll use the x for the times. Times -1/2. All right? So now, just like we just said, our 1's can cross cancel and our 7's can cross cancel. Now, be careful here. What happens when I cross cancel? Look, it's a negative times a negative. So will it be a +1 or a -1? It will be a +1. I want you to go ahead and write that. Okay? Sometimes it might be only one negative and you would have to write a -1 there, and that's a big deal. Okay? Now bring down the rest times 4/5 times -1/2. So you see, guys, it's not necessarily difficult math, but you just want to stay in order as much as you can. All right? Is there anything you could cross-reduce, Mikhail? Very good. 2 and 4 would cross-reduce. And now my answer is positive or negative? Whoa. -2/5. All right, it's negative because there was only one negative being multiplied there. 4/5 was positive. All right, but do you see how it made it way easier? Right off the bat, I got rid of my 1/7 and my -7, and I just had to multiply 2 fractions then. All right, I promise you that was way easier than me just working out the whole problem. Okay, number properties, that's why I wrote this word in parentheses. Don't you love shortcuts? Yeah. Why drive the long way? Do any of your parents like to drive the quote-unquote scenic way sometimes? So they can just enjoy the drive or not be so stressful on the interstate? Okay, so maybe sometimes, but then you're like, no, I just want to get there, right? Like, my mom took us the scenic way to the St. Augustine outlets one time, like all the way down San Jose, all the way through like what's called Switzerland, Florida. I don't know if you guys know where that area is. Like the way back way. It took us almost 2 hours to get to the outlet mall. 45 minutes normally. So, okay, almost done, guys. A school record for the 40-meter dash is 15.24 seconds. I need you to predict what the record would be after 15 years if the school record decreases by 0.06 seconds per year. All right. Now, I'm going to write kind of a ridiculous way that you could do this. Don't do it, though. Okay. So year 1, how much did it decrease by? 0.06. Year 2, how much did it decrease by? 0.06. Year 3, how much did it decrease by? All right. How many of you want to do that 15 times and add it all together? We know that if a number repeats, the same number repeats, and we know how many times it repeats, we don't have to do it that many times. What can I just do? Multiply it. So we're going to say 0.06 times 15. Okay? And it only happens if it's the same value repeating or being multiplied that many times. For example, if in year 5 it decreased by a different amount, then multiplication wouldn't work. You would have to add it. All right, so go ahead and do that multiplication. All right, what did you guys get? 0.90. Did you get 0.90? I'm going to kind of take a short. I already knew what the answer was supposed to be. Okay, so 0.90. Let me ask you this. Is it positive or negative? You got to look back to the problem. The school record decreases. So this is negative because it's decreasing. Now, I need you. I'm not going to give you any hints. I want to see who can figure it out. I need you now to answer the question. What will the new school record be? So you have to use that information. What will the new school record be? Use the information it gives you. All right. Hudson?
14.24.
How'd you figure that out?
I minus 90 by 15.24.
Very good. So he said, well, the old record was 15.24. I know how much it decreased by. So let me just go ahead and do this subtraction. And it's 14.34 seconds would be the new record. All right, you see how we did that? Michael.
So 90 seconds?
No, not 90 seconds. 9/10 of a second.
Oh.
Yes. Yeah, that decimal makes all the difference. Okay? All right, very good. Okay, here's your challenge question. I'm going to let you read this to yourself. I'm going to pause things. Okay, so if you're watching the video, go ahead and pause the video. I'm going to give you guys about 5 minutes to see if you can crack this riddle and come up with the answer. Do not say the answer out loud. Please raise your hand. I will come look at your paper and confirm or deny your answer. Do not share your answers. All right, so you start with 250 points. That's your starting. All right. How much is each mistake worth? 50 points. How many mistakes did you make? So how many points did you lose? 150. So most people got to this point, okay? We had 100 points left. So if there was no bonus at all, that would be my score. The bonus is usually what throws you off. Okay, so you finished the puzzle in 8 minutes and 45 seconds. Each second under 10 minutes gives you 1 bonus point. So you have to figure out how many seconds under you were. How many seconds are in a minute? 60, okay? But then you've got another 15 seconds to get it down to 8 minutes and 45 seconds. Does everybody see how I did that? From 8 minutes and 45 seconds to 10 minutes, that takes a minute and 15 seconds. How many seconds is that? 75. So because I get 1 point bonus for every second, I'm going to add 75 bonus points to get, what's my magic number, guys? 175. Do you see? Okay, it's 175. So you had to count off your mistakes, but then you got bonus points because you finished quickly. It was 75 seconds. Your time that you finished was 75 seconds under the time limit. Okay? All right, it was meant to be a challenge question. Oh, no. Each second under 10 minutes. So you finished 75 seconds early. All right, good job, guys. Okay, that's everything for your multiplying lesson.